Hi, I'm Liz Sneddon. Let's have a look at the triangular distribution. So a little reminder about different types of data, and in particular when we're dealing with numeric data, we can have both continuous and discrete. So if we think about our continuous data, so our values that are decimals, fractions, or the small numbers and so on, those are our continuous type data. So a triangular distribution is for continuous data. And a triangular distribution has three different parameters. One of those is the minimum value, which we call A. Another is the maximum value, which we call B. And the third parameter is the value of C, which is the mode, which is your most common value, the tallest point in the triangle. The assumptions for this model, like with all distributions, we always assume each event is independent. So a couple of reminders for you. When I'm dealing with the area of a triangle, a reminder that the area is equivalent to the probability. When we're talking about distributions, it's always focusing on what the area is. And for a triangle, the formula for the area is half the base times the height. So we need to remember those. Here's the diagram of a triangular distribution. And so there's our formula we just mentioned. And so if I was trying to find the probability of one side of this triangle, so from point C to point B, then I need to find how wide that base is. And I also need to find out how tall it is, and the height is the formula of 2 over b minus a. So that's the formula for the very tallest mode point. Let's have a look at an example. So the time to get up in the morning follows a triangular distribution at the minimum of 0 minutes and a maximum of 12 minutes, and the most common time is 4 minutes. So we want to draw ourselves the probability distribution and work out the height. So we know it starts at 0 minutes, so that's our minimum A. We've got a maximum of 12 minutes, so that's the tallest point on the x-axis. And we know the most common time is our mode, which is 4 minutes. So what we need to do now is we need to work out what that height there is, and that's our formula 2 over b minus a. So using that formula, our b value, which is our maximum, that's the value of 12. A is our minimum, which is a value of 0. So we're going to substitute that into our formula. And now we want to simplify. So 12 take away 0 is just 12. And 2 over 12 simplifies to 1 over 6. So that is the height, the tallest height of the entire triangle. And that will now mean that the whole area underneath that triangle gives a probability of 1, because that's one of our key ideas behind it all. So using that same data, we want to find the probability that it takes more than 4 minutes to get up. So I want to know that right hand side that I've shaded in there from 4 minutes to 12. I want to know the probability takes more than 4 minutes. So I need to use that formula. So in order to find the probability, I need to know how wide the base of the triangle is and how tall it is. So we know our base there goes between 4 and 12. So that's a distance of 8. So that's the base of my triangle. The height, we just worked that out before. That's a value of 1 over 6. So to find our probability, we're going to say probability equals half times the base, which is 8, times the height, which is 1 over 6. And that is going to simplify to 0.6667, which is also 2/3. So there's the probability that it takes more than 4 minutes to get up in the morning is 0.667. So that was all good. So that was nice when we were able to use that tallest point. Okay, the mode. But what happens if I want to find the area of a triangle, such as the one I've just drawn there, where I have some value x and I can find its base, but what I need to do now is I need to be able to work out what the height of that triangle is in order to be able to work out the area. So in order to work out that height, we need to use a different formula. And so on our formula sheet, there are two possible formulas we could use. So here is what the formula sheet looks like for the exam. And I want you to first of all just look at the diagram on the right. Look at the triangular distribution. If we are trying to find a value in this section between A and C, then the formula that I've just highlighted there, 2 bracket x minus a all divided by b minus a times c minus a, that formula, that will give me the height if I'm talking about a value between a and c. However, if I want to find the probability of a point between c and b, then I need to use the formula underneath. So 2 times b minus x over b minus a times b minus c. So we've got two different formulas that we use depending on which part of the triangle we are in. So let's have a look at an example. So our time to get up in the morning, it's still the same. So we've got a triangular distribution with a minimum of 0 minutes, a maximum of 12 minutes, and a mode of 4 minutes. And we want to find the probability that it takes more than 6 minutes to get up in the morning. So more than 6 means I need to find the 6 on my scale, and I want the area above it, which is what I've now just shaded in. So that's the area I want to find. So my first step, before I can do the probability, is I need to work out the height of that triangle. So I need to look at my formula and say which formula am I going to use, and I've got my probability in this section here between C and B, so this is the formula I want to use. So here's the values I have. I want to find that height, and that's the formula I'm going to use to find the height. So I take the formula. Now I need to substitute the numbers in. So my A value is 0. So I'm going to substitute that into the formula. My B value is 12. So I'm going to substitute that into the formula. My C value is 4. And the value of 6, that's the X value. That's the one I'm trying to find. So we are going to substitute those numbers into our equation, and this is what we get. So now we want to do a bit of tidying up. So I'm going to do this stuff in brackets first. So 12 minus 6 on the top becomes 6. 12 minus 0 on the bottom becomes 12. And 12 minus 4 on the bottom becomes 8. Then I'm going to simplify that, and that gives me an answer of 1 over 8. So what I've just now gone to find is I have found the height of that triangle using the x value of 6. So now that I've got the height, now I can go and find my probability. So remember, area of a triangle, half the base times height. So my base is between 6 and 12, so that's a base of 6. I've got my height of 1/8. So the probability of being more than 6 is a half times the base of 6 times the height of 1/8. Simplifying that gives me 0.375. So the probability of taking more than 6 minutes to get up in the morning is 37.5%. Let's try a third example. So the time to get up in the morning follows a triangular distribution. So we've got our triangular, we've got a minimum of 0 minutes, our maximum of 12 minutes, and our mode of 4 minutes. We now want to find the probability that it takes at most 3 minutes to get up in the morning. So we're going to place the number 3 on our diagram, and it says at most, that means from 3 and below. So that's why I've shaded in the area from 3 and below. So that's what we want to find. So we need to think, right, I'm in this section of the graph, so therefore I need to use this formula. So to find the height at the value of 3, that means we are going to use this formula to find that height. So let's write down our formula, and now we're going to do a substitution. So A is equal to 0, substitute that in. B is equal to 12, substitute that into the formula. C is equal to 4, and X is equal to 3. So we're going to substitute those numbers into our equation. And now we're just going to do a bit of tidying up. So the nice thing about subtracting 0 is that part will simplify nicely. And when I simplify that fraction, I end up with a value of 1/8. Again, same value. Just by chance. Honestly, I didn't pick the numbers properly. I just chose some numbers. So that gives us a height here of 1/8. So there's our information. We've got our base, we've got our height. So we've got our area of a triangle, half the base times the height. So our base here goes from 0 up to 3. So that's a distance of 3. We've got our height of 1/8. So the probability of taking less than 3 minutes, at most 3 minutes in the morning to get ready, is equal to 1/2 times the base of 3 times the height of 1/8. And that simplifies to 0.1875. So that's the probability we take less than, at most, 3 minutes to get ready in the morning. Thanks very much for watching.